Hello everyone. Okay guys, we're all on page 11 today, and I'm going to walk you through some notes of how to switch from degrees to radians. So first, let me remind you what we were talking about yesterday. So yesterday we learned that if you do a full circle, excuse my horrible circle drawing skills, if you do a full circle, that's 360 degrees all the way around. If you do half a circle, that would be 180 degrees for half the distance. So if you make half a circle, it's 180 degrees. We also started to talk about a new way of measuring angles. So we're all very much used to using degrees, right? 90-degree angles, doing a 45-degree turn. But in math, we're going to be using a lot of measurement called radians that also is used to measure angle lengths. And yesterday we discussed that half a circle equals 1 pi radian. Okay, so in that same way, if this half a circle is pi, then the whole circle would equal 2 pi. And we also discussed that if this is 90 degrees, well, that would be half a pi length, so we'd write that pi halves, and so on. So today we're going to show you how to convert using a little math to get from your degrees to radians every time. And to do that, we're really going to focus on one fact, that 180 degrees equals pi. And we're going to use this to create a conversion tool, something that we can multiply to give us the other type of degree. So if we're over here, we've got our conversion tool right here. It says if we're going to switch from degrees to radians, we're going to multiply by pi over 180. All right, if we're going to go from radians to degrees, we do almost the same thing, but we're going to multiply from 180 divided by pi. So we just flip the same conversion tool. So let's go ahead and give one of these a go. All right, you guys, so we're going to look at this first example. In this example, we're going to try to switch 90 degrees into radians using this conversion tool. So first thing we're going to do is we're going to multiply by pi over 180 degrees. And then we can go ahead and write that as one fraction. So on top we have a 90 and a pi, and on the bottom we just have 180. And then our last step here, you guys, is to simplify. Easiest way to simplify fractions is to factor these numbers on both the top and the bottom. So for instance, we can factor 90 to be 9 times 10. We also got a pi on top still. And we can factor 180 to be 18 times 10, or in other words, 2 times 9 times 10. All right, once we get in this factored form, we can do some canceling. Remember, if the same numbers on top and the bottom, they can cancel out. So since we have a 9 being multiplied on top and a 9 being multiplied on the bottom, those cancel out. Same thing with our 10. And we're left with our simplified fraction, pi over 2. And that is our equivalent radian to our 90 degrees. Okay guys, let's go ahead and try the second example, and this one's even easier than the first. So it's the same process. We start with 180 degrees, and we're going to multiply by our conversion tool just like we did before, pi divided by 180. And then we don't even have to simplify on this one, right? When we rewrite this problem, we've got 180 on top and a pi on top, and we got 180 on the bottom. And since these numbers match top and bottom, they're just being multiplied, they can cancel out fully, and we're left with the answer just pi. Like we already know from looking at our unit circle, how we said half a circle was 180 degrees, or half a circle is pi. All right, guys, let's do our third example up here. So this time we're switching 225 degrees to radians. So we're going to multiply by pi divided by 180. 180 degrees. Just like before, let's go ahead and rewrite that into one solid fraction. So we've got 225 on top and a pi on top and 180 on the bottom. And let's go ahead and try to factor 225 and 180 to get them nice and simplified. So for instance, 225 can be written as 25 times 9. And 180 could be written as 20 times 9. All right, so since they both have 9s being multiplied on top and bottom, we can cancel those out. And we're left with 25 pi. Oh, wrote an extra pi in there. Sorry about that, you guys. 25 pi over 20. We can keep simplifying on this because we can keep factoring 25 and 20. So we can write 25 as being 5 times 5. And on the bottom, 20 is 5 times 4. So we can cancel out a pair of 5s here. And we're left with 5 pi over 4, and that's as simplified as it gets. So we know that 225 degrees is the same thing as 5 pi over 4 radians. The other direction. So let's try going from radians to degrees. To do this, we're going to almost the exact same thing, but we're going to flip our multiplier. So this time we're going to multiply by 180 degrees and divide by pi. So let's give this one a go. So we're going to start with pi fourths. And we're going to try to convert that back into our degrees. So we're going to multiply by 180 degrees divided by pi. Now when we do this, you guys see that we have a pi on the top and a pi on the bottom. So these are actually able just to cancel out right from the get-go. The pi on top and the pi on the bottom cancel out, which is really good news for us because we're just left with 180 degrees divided by 4. Okay, and that actually, you can plug it in your calculator. That gives us 45 degrees. So we know that 45 degrees is the same thing as pi fourths radians. All right, let's try that one more time. So this time we're going from 2 pi thirds radians and switching it into degrees. So we're going to multiply by 180 degrees divided by pi. Right, and if we set these up right, the pi's should always cancel out. So we have a pi on the top, a pi on the bottom. Those will go ahead and cancel out. And we're going to be left with 2 times 180 on top divided by 3. So first, let's go ahead and multiply 2 times 180 degrees. That's 360 degrees. And then we can divide by 3, which gives us 120 degrees. So we know that 120 degrees is equivalent to 2 pi over 3. All right, let's go ahead and do this very last one. So we have 7 pi over 6. And we're going to convert this radian measure to degree measures. We're going to multiply by our conversion tool, 180 degrees divided by pi. And again, if we set this up right, our pi should always cancel out because there always will be one on top and always one on the bottom. This is going to give us 7 times 180 degrees divided by 6. So we're going to say what's 7 times 180. We can always just go to use our calculator. Okay, so we're going to say 7 times 180. That's 1,260. degrees. And then we're going to divide it by 6. And that spits out 210 degrees. So again, we know that 7 pi over 6 radians is equivalent to 210 degrees. And that's how you convert between the two measures for angles. Okay, we're always going to use our tools, pi over 180 or 180 over pi. All right, you guys, so your assignment for today is to give this a practice. You're going to tackle page 12 and page 13. Okay, so your assignment for today is page 12 and 13 using this tool.